Okay, second video for chapter 20. So now we're going to tie together a link that between significance tests and confidence intervals. So the result of a significance test is basically a decision to reject our null hypothesis or fail to reject our null hypothesis. When we reject our null hypothesis, we're left wondering what the actual proportion P might be. A confidence interval might shed some light on this issue. So we actually know more from a confidence interval than a significance test, because a confidence interval will, if you reject your null hypothesis, you don't know what your proportion is, but a confidence interval can tell you where your proportion should lie. So let's take a look quickly at an example. We'll look at the significance test, and then we'll look at what our confidence interval would tell us. So we did this example. Well, we've seen this example in our chapter 19 videos. So according to the website sleepdeprivation.com, 85% of teens are getting less than 8 hours of sleep a night. Janie wonders whether this result holds in her large high school. She asks an SRS of 100 students at the high school how much sleep they got on a typical night. In all, 75 of the responders said less than 8 hours. So I want to first run a significance test. So our conditions are met. They say that it's an SRS of 100. It's independent because 100 is definitely less than or equal to 10% of all high school students. And finally, our large counts. So we would expect 85 successes. There's 100 and our proportion is 85%. And then we'll expect 15 then fails. And so both of those are greater than or equal to 10. So because our conditions are met, we can now run a significance test. So the first thing I'm going to do is I'm going to write down my hypotheses. So my null hypothesis here, that's going to be no change. So that's the 85. And my alternative hypothesis here is going to be that we're suspecting it might be less than that. Okay, based on that 75. So I'm going to rely on my calculator here. And it's going to give me a test statistic of negative 2.8. Okay, so in my calculator, or using your formula. So I'll just show you what the formula really quickly. So p hat minus p over your standard deviation. So p hat would be the 75 from the sample minus your parameter. And over, okay, and so that's where my negative 2.8 comes from. Okay, so now I'm going to want to find the probability that my proportion is less than 85, which we now know corresponds with a test statistic of negative 2.8. So this is going to get me a p-value of 0.002. So what I know now is that my p-value is definitely less than my alpha. It's not specified here, so we'll use our alpha of 0.05. So because it's less than, I'm going to reject my null hypothesis. I have convincing evidence that my null hypothesis is not true. So I will reject the null hypothesis. So we're in favor of our alternative hypothesis. So I may have a decent idea that my null hypothesis is less than 0.85, but it doesn't really tell me what my actual proportion is, or I should say where my proportion would actually lie. But a confidence interval would give me a better idea of where my actual proportion, my parameter, would be, since we know it's not the 0.85. So I'm going to create a confidence interval. So it's a confidence interval, so we're going to rely on the sample. Here is my form to follow. 1 minus p hat. Okay, so my sample found 75%. We're going to use a 95% confidence interval. So your Z critical value for 95% is 1.96. And I have 0.75 times 0.25. And my sample of 100. So just working through the calculations there, I'm going to get a confidence interval of 0.67 to 0.83. So we're 95% confidence that our true proportion would lie between 0.67 and 0.83 when we know that our null hypothesis is not true. Notice that 85 is not in there, so 85 would not be a plausible value. So that's stuff going back to chapter 18 rather. So 85 is not in the interval, so it's not a plausible value. So that would make sense because we rejected that 0.85. So we're going to reject anything outside of our confidence intervals. So just one thing to look at for that. So there is a link between confidence intervals and two-sided tests. The confidence interval gives an approximate range of your null proportions that would not be rejected by a two-sided test at the alpha 0.05 significance level. The link isn't perfect because the standard error used for the confidence interval is based on a sample proportion. It's a sample, not a population, while the denominator of the test statistic is based on the value of your null hypothesis. So it's not perfect, but just in general, we can see that, and this isn't based on the last example. This is just some other different example. So if your confidence interval gave you a range from 0.42 to 0.58, what we would then say is that we'd reject anything to either sides of our confidence interval. And so that's why they say that there's a link. It's would be the same thing. A 95% confidence interval would be the same thing as rejecting to both sides of your for your significance test. That's it for this video.